Hey guys, it's Sam Rago here, and you may not have learned how to determine the sample size needed for the difference between two population proportions. Now, in order to solve for this equation here, we have to assume that the n for both populations are equal to each other. Once the proportion here is not given to us in the problem, we substitute that whole area with 0.5 and we get this alternate version of the formula. Now the problem is, a local physical therapist wants to determine the difference in proportion between men and women who regularly exercise. Now, in order to do so, he needs to know what sample size he needs in order to perform his experiment. So he wants to perform the experiment within 2 percentage points, as I've written out here, with 99% confidence. Now, since we have 99% confidence, it's a given that our alpha is 1%, or 0.01. So when I'm dealing with this formula, the first thing I like to do is take care of this z alpha over 2. So we're going to put the 0.995, which is area to the left, we're going to put 0 as our mean, and we're going to put 1 as our standard deviation. Once we plug it into the calculator, we find out that z of alpha over 2 equals 2.58. Now once we have that, we're just plugging and chugging into the formula we have. We're inserting 0.211 as our p of hat 1, and we're inserting 0.185 as our sample proportion number 2. So for this whole first part here, the answer comes out to be 0.317254. Now for the second part here, we just took 2.58, which was our z of alpha over 2, divided by the margin of error, which was 0.02, and we squared it. Now that value was 16,641. Once we multiplied these two, we found out that the sample proportion needed was 5,280. Now when we're not given the proportions to start off the problem, we use the alternate version of the formula that I showed you earlier. Instead of inserting the proportions, we just use 0.05, we still have our z of alpha over 2, and we have our margin of error. The way to find the z of alpha over 2, same as before. You just find the inverse norm, so area to the left of half of the alpha. So it's 0.995, mean is 0, standard deviation of 1 gives us 2.58. Now once we have the z of alpha over 2, we just plug that in right here. 2.58 divided by the margin of error, which is 0.02, all that squared times 0.5 gives us 8,321. And make sure to always round these numbers up.